Let's talk about percent yield. Here are our objective and essential question. Again, I encourage you all to take time and pause the video to record anything that you need on this video in your notes. So our objective today is to be able to describe and calculate the percent yield from a chemical reaction. And the essential question you all should try to answer in the summary at the end of your notes after watching this video is, what does a reaction's percent yield describe? And how do we calculate a reaction's percent yield? So when we talk about the word yield is essentially a synonym for produce. So when we talk about our reaction that we watched in the last video on stoichiometry, we had two carbon atoms reacting with an oxygen molecule to form two carbon monoxide molecules. So the word yield in a chemical reaction is represented by this arrow here in our chemical equations, and write yield here. Okay, so what that's saying is the reactants yield the products. Again, keep in mind, yield is like produce. So reactants produce the products. Okay, so we do have two different types of yield we can get from a chemical reaction. We have our theoretical yield. Now, this is the number that we calculate using stoichiometry. So in our last video, we saw that our theoretical yield for producing carbon monoxide from 3 grams of pure carbon was about 7 grams. So this is in a perfect world. We're doing these calculations. So when people say, oh, theoretically this would happen, this is exactly what we mean in chemistry class. The theoretical yield is what we would produce in a perfect world from the chemical reaction. So in a perfect world, in this reaction above, we are producing 7 grams of carbon monoxide. Now, this probably is it's pretty unlikely that we would actually produce our theoretical yield when we're actually performing this in a chemical lab setting. Now, I really hope that we are not going to be producing carbon monoxide because that is a very harmful gas. But if we were, the actual yield is the number we actually would measure after our reaction in real life. It is usually not the same as our theoretical yield. It's usually greater or less than the theoretical yield due to something called error. Now, we could have systematic error, which is just an inherent inaccuracy in the experiment system. That could be maybe our scale was off when we were measuring out the amount of carbon that we're starting with, which no matter how many times we repeat that experiment with that same scale and repeat that chemical reaction using that same scale to measure mass, it is always going to give us the incorrect mass. Random error is exactly as it sounds. It's extremely unpredictable. And this is why we do multiple trials of experiments, right? Say I'm doing a chemical reaction and I accidentally knock over one of my reactants on the floor. That is random error. I could not have predicted would have happened, and it would definitely mess up my experimental results or the results of my chemical reaction. So if we had a theoretical yield of 7 grams of carbon monoxide, maybe our actual yield looked more like 5.3 grams of carbon monoxide. Maybe I spilled some reactants. Maybe something happened. Maybe I left the window open of the lab and it blew away some particles. I don't know, but this is our actual yield after performing that experiment in real life and that chemical reaction in real life. So when we're trying to calculate the percent yield, we are essentially comparing our actual yield to our theoretical yield, and it's giving us a number of, essentially gives us an actual number of how accurate our chemical reaction and experiment was. So if I'm trying to calculate my percent yield from that chemical reaction on the previous slide, and my actual yields, I don't even remember what I wrote down. Maybe it's 5.4 grams of carbon monoxide, but my theoretical yield I calculated was 7 grams of carbon monoxide. All I'm going to do is divide this 5.4 grams of carbon monoxide by 7 grams of carbon monoxide, and then I'm going to multiply it by 100 to get it to a percent value. Now, if you were following along in your calculator, you would see that we produced carbon monoxide at about a 77% yield. So we are about 77% accurate with our chemical reaction in real life compared to what we calculated in our stoichiometry calculations. I hope this helps explain a little bit of what percent yield is, and I look forward to discussing this more with you all in class coming up.